is to go to the AP Chemistry site, and if you look at the daily plan for Thursday, you'll see on the daily plan for Thursday that if you go to that, there's a link where you can go to this Crystal Violet makeup instructions. And so if you go to that, you come to this right here, and the first thing that you're going to need to do is you're going to need to download the Logger Pro. I have it hooked on right here. You'll have to download that. So you'll download that, and you should get something that looks like this right here. Alright, it's something that I've already made, and what I've made here is I've made a Beer's Law plot for Crystal Violet, and so I collected 5 points, and then I did the linear fit. You'll see that we'll need the slope for that in a second. So the slope, we'll come back to that in a second, but you'll need that number. Alright, and then here is what I did here is I took some Crystal Violet and put it with sodium hydroxide, and I put it in the cuvette, and I found that the absorbance changed over time, because when it reacts with sodium hydroxide, the purple Crystal Violet eventually turns clear, and so the absorbance went down over time. Alright, and so what we're going to do here with this lab is we mix these two together. We're going to try to determine the rate law for the reaction of Crystal Violet and sodium hydroxide. And for part 1 of the lab, we're just going to try to determine what the rate is according to Crystal Violet. So we're going to be looking for the M. If we get time later, we'll do the sodium hydroxide and look for the rate according to sodium hydroxide. So the purpose of the lab is to determine what M and N are, but for this lab that I want you to make up, we're just going to be worried about the Crystal Violet. Alright? Now, the first thing I did is I made a Beer's Law plot, which I showed you that on the other page. Okay? And then the second thing that I did is I had the Crystal Violet, so I put Crystal Violet with sodium hydroxide, and what we did is we had the absorbance over a given time. And because as they react slowly, the absorbance, you can see by looking at the Logger Pro graph in a second, it decreased with time. And so it looked something like that. So what we're going to do is we're going to use this graph right here, and we're going to build 3 more graphs. And so what we're going to do is we're going to build a graph of concentration of Crystal Violet over time, a graph with the natural log of Crystal Violet over time, and a graph of 1 over Crystal Violet versus time. And what we're going to do is we're going to see which graph is the most linear. If it turns out that this Crystal Violet concentration over time is linear, then that's going to mean that we have a 0 order reaction. If this graph, the natural log of Crystal Violet over time, turns out linear, that means we have a first order, and if it's second order, it will be 1 over Crystal Violet versus time. So your job is to figure out which order the reaction is in terms of Crystal Violet. So let's go look at the Logger Pro. Alright, so on your Logger Pro, the first thing that we're going to have to do is we're going to have to insert, so we're going to go to experiment or data, and we're going to insert a new calculated column. Alright, and we're going to title that, well, we can just call it the concentration of Crystal Violet. We'll just abbreviate that with CV, and then what we can do is we can just go brackets, which means concentration of Crystal Violet. Now we're going to have to write an equation for that. Alright, and so the equation that we're going to be using for that, we're going to need the slope that I have shown right here. Alright, and so what we're going to be doing is we're going to be taking our absorbance that we have calculated, and we're going to divide that by the concentration of our Crystal Violet. Well, not that, we're going to divide it by the slope, which happens to be 0.05967. And basically what that's doing is it's going to, when we do that, that's going to basically use Beer's Law, where we have the absorbance is equal to is directly proportional to the concentration, but doing it this way, it ends up calculating the concentration. So we'll hit done there, and hopefully, all right. So now that put that in there for us. So now we can go ahead and check right away to see if we have a zero order reaction, because we can click on this column right here, and we can put the concentration, and we can make our graph the concentration of crystal violet versus time, and you see we don't have a straight line. Okay? Since we don't have a straight line, we know that our reaction can't be this one right here. It can't be zero order because we have a curved line, and so it can't be zero order. So we ruled out zero order. Now we need to build this graph and see which one turns out to be linear. Okay, so to do that, we're just going to go to Data, New Calculated Column, and what we're going to do is we're going to call this one the natural log of the concentration of crystal violet. So I'm just kind of abbreviate this here, and so the short name can be natural log crystal violet. I guess it's the same as the long name. And so what we're going to do is we're going to choose the function of natural log, and we're going to multiply that by the concentration of crystal violet. Alright, and then we're going to hit done. And so it should put that column in for us. Now we could check that one right away, and if we double click here, or just single click maybe, we can put that in, and we can auto scale that, and it looks like we get somewhat of a straight line. Okay, that's pretty linear right there. Alright, but let's see, maybe it's not as linear as the 1 over the concentration of crystal violet. So let's check that one out. Alright, so what we'll do is we'll go Data, New Calculated Column, and then this one will be 1 over the concentration of crystal violet. Alright, so the short name can be the same thing, 1 over the concentration of the crystal violet. And so we'll just go 1 divided by, pick our variable, concentration of crystal violet, hit done. Okay, now what we can do is we can plot that one and see what that one does. So we go 1 over crystal violet. And you can see that one is kind of a curve. Alright, so now we just have to decide, well, which one's the most linear? That one, this one, or this one. Okay, and you can see that the natural log of crystal violet is the most linear. Therefore, if we go back and look, it ends up that our reaction is first order in terms of crystal violet because it produced the most linear graph. Alright, so that's how you'll figure that out. Now, what you need to do is you need to print out the graph that is the most likely order, and tell me what the order is according to crystal violet. In addition, you'll need to do the pre-lab and the post-lab questions for this lab. And then that's it to make up the lab. That's it.